Hello everyone and welcome to this video. In this video, I want to talk about a problem that I always have in winding simulation in finite element softwares. Should I fill the whole geometry, the whole area of a slot inside transformer or electrical motors with the winding, or I should just consider the efficient area of wires inside the slot? Because as you know, we cannot use the whole area of the slot with the round wires. So how should we model these kind of windings? In this video, I will use EMAG from EMWORKS and check the option that this software has. Inside the coil's settings, we can edit the definition of the coil, and in the general properties, we can define the wire size or the fill factor. So let's check this box and see the results. For example, at the first simulation, I want to use 90% of the slot area for winding 1 and the same for winding 2. Let's edit the winding 2. Change the fill factor to 90%. This software has the ability to calculate the resistance from the geometry, number of turns, wire size, or fill factor that we defined. So for this simulation, I will analyze this transformer to just calculate the resistance. So even the first step is enough for me. I don't want to simulate the whole cycle of 50 Hertz. I just need the calculation of the resistance. After the first step is solved, I will stop the simulation, go to the result table, and in resistance, remember, it calculated 0.52 ohm for the coil 1 and 3.73 for coil number 2. This calculation is made with 90% filling factor. So remember these values and let's change the filling factor to see does it affect the resistance or not. I will make it 1/3. Change both coils to 30% of filling factor and watch the results. So we expect to have triple resistance from this value. Let's analyze the simulation. I'm curious about changing number of turns because it is a very common mistake. If we double the number of turns, the resistance will be doubled too. But it's not like that. We will check. Stop the simulation and check the resistances from the table of results, and resistance exactly it is tripled. So for just one coil, I will change the number of turns. Coil 1 has 1.5 ohm as the resistance. Let's make the number of turns to 500. If we make a mistake and consider the resistance will be double, in many designs it happens for me myself, and I consider that the resistance will be doubled. Of course, it will be 4 times more. Let's see the results of the resistance, and yes, it's exactly multiplied by 4, because when we increase the number of turns with the same area, the area dedicated to each wire is reduced. It will be half. But the length of the coil will be twice. So we have lower area for each wire and longer length for the total wire length. So if we multiply the number of turns by 3, we expect the resistance to be multiplied by 9. And this calculation of the resistance and filling factor inside the coil excitation is very useful in this software. If you have experienced small details like this in other softwares, please write your comment or share your experience.